Hello, hello students. We are going to start with the chapter of projection of solids. The chapter carries a weightage of around 20 to 24 marks. It's a very important chapter. In fact, this is a module of solid which has two chapters, projection of solids and section of solids. We are going to start with projection of solids for now. Now, this chapter, there are total 4 solids which can be again categorized under 2 types. The first type is what we call as polyhedron. Poly, the literal meaning of poly is many, and the literal meaning of hedron is planes. A solid made up of many planes will come under the category of polyhedron. Under this category, there are 2 solids. The first is pyramid, the second is prism. Now, this pyramid solid is absolutely important, right? It's a very interesting solid to deal with, right? Now, we have the other category called as solids of revolution. Under this category, we have 2 solids again, cone and cylinder. Now, why are they called as solids of revolution? The reason is very simple. Say, let us see how a cone is formed. A cone is formed in a very simple manner. You can just say that if I would take a triangle, and if I would fix one edge, if I would fix this one edge and I would revolve this entire triangle by 360 degrees, this triangle would encompass a volume. That volume would be in the shape of a cone. Am I right? Similarly, can you tell me how will a cylinder be formed? Yes, very simple. For a cylinder, instead of a triangle, I'll take a rectangle and I'll rotate it by 360 degrees. Okay? The volume encompassed would be a cylinder. Hence, they are called as solids of revolution. Now, the main difference between these 2 categories is in this, there are planes, many planes. In this type of solid, the surface of the solid is smooth. The example of a cone, an ice cream cone, right? Or for a cylinder, you can imagine a chalk. The surface of the chalk is extremely smooth here. Okay? So we have these 4 solids in our syllabus, out of which, as I have mentioned, pyramid is a very interesting and important solid to deal with. Once you get to know pyramid, all these solids are going to be absolutely simple. Now, before we go ahead, I would quickly want to revise some basics that we did in the chapter of projection of points. Remember this? Any point in the HP, the front view lies on the XY. Any point in the HP, the front view lies on the XY. A front view is denoted by a small letter and a dash. Okay? Once again, any point in the VP, the top view lies on the XY. The top view is denoted only by a small letter. Please remember, once again, any point in the HP, the front view lies on the XY. Any point in the VP, the top view lies on the XY. Now, as I have always said, engineering graphic or engineering drawing is a subject where imagination has to be given always a secondary preference. You have to build your imagination, right? So what I have done is, I have divided this entire chapter into some set of points. Say, the first set of points here, I am going to call them as important points. Now, these important points are your general points. They are your general points. Any problem will always fit, okay, in these points. So let us talk about the first point. The first point is solids are always kept in the first quadrant. So we talk about any of these solids. These solids will always be kept in the first quadrant. What is the implication of that? We know that. Remember this. We know that any point in the first quadrant, front view lies above xy and top view lies below xy. Remember this? This is what we did in projection of points. What it implies is, you take any problem, you take any solid, our front view dash will always be above xy, our top view, small letters, will always be below xy. Irrespective of the problem statement, this is what is going to happen. Let us look at the second point. Solids are always tilted to the right. Now I'll come to this when we actually solve a problem, right? Let us talk about this. A corner is nothing but a point, remember. A corner is denoted by a single letter or a single number. Example, if in our problem we will have a dash, it would mean that it is simply a corner because it is denoted by a single letter or a single number maybe. An edge is denoted by two letters or two numbers. Say we have a notation somewhere in our problem, a dash, b dash. Now there are two letters, so this would mean that it's an edge. Please remember. Similarly, a face is nothing but a plane, is denoted by minimum of three letters or numbers. Can you tell me a plane which is made up of three letters? Yes, it's a triangle. A triangle would be something like a dash, b dash, c dash. A rectangle would be a dash, b dash, c dash, d dash. Or in the form of numbers, it will be 1 dash, 2 dash, 3 dash, 4 dash. A rectangle, that is. Similarly, a pentagon would be 5 letters or 5 numbers. So if we have these all things coming together, we have to understand that it's a face or a plane. Now, these are your general points. They will always come in any problem. They will help you with the problem. Now we need to solve the problem. Now for solving the problem, we have something called as the master points. Now these are extremely important. By heart these points. I'll tell you how to use them in an actual problem. The first master point is, if the base corner or the base edge, I'll talk about this later. If the base corner or the base edge is in HP, assume the entire base in HP. Similarly, if the base corner or the base edge is in VP, assume the entire base in the VP. I'll repeat once again. If the base corner or the base edge is in HP, assume the entire base in the VP. Similarly, if the base corner or the base edge is in VP, assume the entire base in the VP. Master point number 2. I'll tell you how to use these points. Very, very important. You can solve any problem in the universe of projection of solids if you are aware of these master points. Whatever is kept in the HP or VP, place it to the right. Whatever is kept in the HP or VP, place it to the right. Very, very important. Two outlines. Outlines are dark lines. Two outlines never intersect each other. Two hidden lines will never intersect each other. I'll repeat. Two outlines will never intersect each other, and two hidden lines will never intersect each other. This is true for the chapter of projection of solids. Very, very important. And now, to augment master points, I have made master diagrams. What I'll be doing is, I'll be combining master points along with master diagrams. Let us look at the first master diagram. I'll tell you how to read this master diagram. Okay, I'll tell you how to read this master diagram. Remember what was our first point? Our first point was, if the base corner or the base edge is in HP. Now if while reading a problem we understand that a base corner or the base edge is in HP, assume the entire base in HP is what the first master point says. As soon as you assume the entire base in HP, you will have a look at this master diagram, because this master diagram is, if the base is in HP, then we'll follow this master diagram. Now, how do you start with the master diagram? Is you first draw the XY line as usual. These numbers are the sequence in which you will start your problem. For example, the first step is you will draw the base of the solid. The second step is you will draw the height. After second step, you will draw the third step. The third step would be some condition with HP that would be given in the problem. Now, as you draw the third step from the second step, you are just supposed to copy and tilt. Now, this is according to again some condition. Step number 4 is the corresponding top view that we get here. From step 4 to 5, again there will be some tilting and copying. Some condition would be given. According to that condition, we'll tilt and copy step number 4 here. Step number 6 is the final step where we will draw the corresponding front view. Now, again, as I said, similarly, master point 1 says, similarly, if the base corner or the base edge is in VP, we read the problem and we'll see something of this kind is given. Then what we will do, we'll assume the entire base in VP. Now, if the base is in VP, we are going to follow this master diagram. Again, the numbers here tell the sequence in which you should follow, or in which you should complete the problem. Base, it is exactly opposite to this. Base height, here a condition will VP will come. Corresponding front view, condition with HP, and corresponding top view. Now please remember guys, after solving n number of problems, this is a summary that I have come about with. What I'm trying to imply is, every problem will always fit into the master diagram. You just have to decide where the base is. And how will you decide where the base is? By understanding the first master point. And how will you understand the first master point? When you actually read the problem. Okay. A small thing, the arrows, they denote the direction of the observer. Okay. The arrows denote the direction of the observer. Okay. This is all we have for our first lecture on projection of solids. I'll be doing the short lectures so that it will be very easier for you to revise these lectures once again. Thank you. Thanks a lot.